So today's notes are going to be on two variable inequalities, and our content objective is going to be to graph two variable inequalities, and the language objective will be to define terms that are associated with two variable inequalities, such as linear inequality, boundary, half-plane, and test point. So I'm going to start by defining linear inequality. A linear inequality is an inequality in two variables, like x and y, whose graph is a region on the coordinate plane bounded by a line. So I'm going to draw a couple visual examples for you really quickly. Keep in mind these are rough sketches, so bear with me. So we could have one that looks like this. Notice that it's a dashed line, and it's bounded. The graph is a region on the coordinate plane bounded by a line. So this is the boundary line, or the boundary, and then the one side would be shaded, and that is the graph of that inequality. So there's the boundary line and then the shaded half plane that makes up the graph of the linear inequality. So I'll label these things. We have our boundary line, or boundary, which is just the line that we've drawn. And then we have the half plane, which is the shaded portion, or the shaded half of the graph, which is, again, simply put, the shaded side. So in this example, I have a dashed line. We could also have a solid line. So also, I forgot to label my axes. That's not good. Could also have a solid line. And I could shade the other way. I could shade below. So again, the shaded part would be the half plane, and the line itself would be the boundary line. Label my axes. But it's a shaded side bounded by a line called the boundary and the half plane. One thing I want to note here, our line is dashed. And this is because it is less than or greater than. So if it's less than or greater than, you're going to have a dashed line. Again, it's not including the line, which is why it's somewhat open. Whereas if we have a line that is solid, we're going to have less than or equal to or greater than or equal to. So just like you have in filled in points for an inequality when it's less than or greater than or equal to, you have a solid line when it's equal to and a dashed line when it's not. So let's jump in with an example, or continue on with an example. I want us to determine what is the graph of the inequality y is greater than 3x minus 1. And step one over here, leave myself space. Step one is going to be to graph the boundary line, or just the boundary. So I know my y-intercept will be -1. The slope is going to be 3 because this is just like a normal line for the most part. So I'm going to make sure I give myself space to include that. Draw this pretty large. Label my axes, x and y, 1, 2, 3, -1, -2, -3. And I know my y-intercept is -1. Sorry, slide this down. And then I'll draw some x coordinates. And I know I'm going up 1, 2, 3 and over 1. And then I can do the same on the side, down 1, 2, 3 over 1. Be about there. And since it's greater than and not greater than or equal to, it's going to be a dashed line. So I have my dashed boundary. And then I'm going to, in my next point, so there's a couple different ways you can tell which side you're shading for your half plane. I'm going to do the way that will always make it crystal clear which way you're doing it, though there is another way that can be pretty straightforward for a lot of people, but we'll do the more or less foolproof way first. So we're going to choose a test point, and I want to make a little star here. Often 0, 0 is the easiest, unless it's on the boundary line or on the boundary. So I'm going to test this with the point 0, 0. So all I'm doing, this is a coordinate point, it's our origin right there. So I know my point 0, 0 is right there. I'm going to plug it into my inequality to see if it holds true. If it checks out and it's true, then I'm going to shade the side that includes my test point. So I'm going to plug in 0 for y, and then 3 times 0 for x minus 1. So again, I'm just plugging in 0, 0 for x and y, and I'm calculating it out. So then I have 0 is greater than 3 times 0 is 0, minus 1 will give me negative 1. If I look at this inequality, it's true that 0 is greater than negative 1, so it's accurate. Therefore, I'm going to shade this to include the point 0, 0. So since 0, 0 is over here, I'm going to shade the side that includes 0, 0. If it was not true, I'd shade the opposite side, but since it is true, I'm shading to include 0, 0. So that's our example. We're going to do 2 quick checks just because I think we have time for that and I think it'll be helpful. So I'm going to flip the page. Our first quick check is going to be graph the inequality. Y is less than or equal to negative 2x plus 1. So go ahead and try that one on your own really quick. I'm going to go over it, but if you haven't done it, please pause and try on your own. So I'm going to start by drawing my axes. So my x-axis, my y-axis, 1, 2, 3, 1, 2. That'd be 3 down there. 1, 2, 3. Okay, so I know my y-intercept is positive 1 this time. I'm going to go down 2 over 1, down 2 over 1, up 2 over 1. That way, and this time I have a solid line because it's less than or equal to, so I'm going to draw a solid line through the points I just plotted. So I have my solid line. Now I'm going to choose my test point, which again, 0, 0 is not on my boundary line, so I'm going to plug in 0, 0, and I have plus 1. So 0 stays 0, less than or equal to negative 2 times 0 is 0, plus 1 is 1. Again, 1 is greater than or equal to 0, or 0 is less than or equal to 1. That's true. So I'm going to therefore shade to include the point I plugged in, 0, 0. So again, I plugged in 0, 0. I plugged it in, and I'm going to shade to include that point. So that is my shaded side. Let's do one more to make sure we're crystal clear. I'm going to graph y is less than 3x. So try that one on your own. Make sure you write down any questions, comments, or concerns you have while you're trying it out. I'm going to go over it. So if you haven't done it, pause. Finish it first. Okay, so do this. All right, and then we have 1, 2, 3. Since there's no y-intercept at this point, I know the y-intercept must be 0, so I'm going through the point 0, 0. Then I go up 3 over 1, down 3 over 1, and since it's just less than, it's going to be dashed. And then I can try a test point. This time I can't plug in 0, 0 because it is on my boundary line, and it would just show me something that's equal, not something that is on one side or the other of the boundary line. It just would tell me that it's on the boundary line. So I'm going to plug in instead the point 1, 0. So I plug in 0 for y is less than 3 times 1 for x. 0 is less than 3. That is true. 3 is greater than 0. So I'm going to shade to include the point 1, 0. So since that's right there, I'm going to shade this side, and I'm done my graph. I'm going to pause and make one more note that some of you might have noticed. If it is less than, another way you can tell which side you're shading is it's going to be below, because this is talking about the y, it's going to be below the boundary line because it's less than. Same here, since it's less than, it's going to be below the boundary line. Whereas if we have a greater than problem, as we did in our first example here, if we have a greater than problem, it's going to shade above. So that's another way you can test that. I didn't share this till the end because sometimes it can be confusing which side is above and which side is below depending on the slope of your line. So if you're ever confused, plugging in the point works very well. We'll always make it crystal clear which way you're shading. But if you want to just do less than or greater than and shade appropriately, less than being below, greater than being above, that will also work. All right, make sure you write down any other questions, comments, concerns, or clarifications you have on these notes so we can go over them together in class.